Good evening, my YouTube viewers. Crystal here. I'm here to give you another solution to the Big Mart prize competition with Analytics VidHaya. Analytics VidHaya, they allow you to input your submission, but they don't have a facility or they don't have Jupyter notebooks for you to show your solution or show your program on the file. So because they don't have that facility, and the screen recorder that I'm using only allows me to record one tab at a time, and I'm on the GitHub tab. So I decided, well, I can't show it to you on the website, but on the Analytics VidHaya website, when you submit your submission and check it on the solution checker, the best score for Big Mart was 1127.71745, and my score was 1154.4027. So I think that was a pretty good score. I was pretty happy with that. It was a definite improvement over previous scores, and it's one of the best scores that I've had, even though I can't show it to you because of the limitations of my screen recorder. But I do like the screen recorder nevertheless, because it is attached to my Google Chrome, and all I have to do is click on it, and I don't have to go on to a website or anything like that to do it. So what I wanted to do is I wanted to go over the solution with you, because I worked all day on the solution and I wanted to make a video of it. The first thing that I did was I input the files, because you have to input the files. Imported some files that I didn't need, such as random forest regressor. And then I loaded the train database, and you can see the train file. And then I loaded the train info, and you can see the train info. You can see that there were a lot of objects, but the computer program will only deal with numbers, so you have to convert the objects to numbers. So all of the objects were converted to numeric data except for item identifier. Then we did a description of the train file, and we did the same thing with the test file. We loaded the test file. We tested the shape of the test file. It had one less column than the train file. And then we looked at the info on the train file. It's exactly the same as the train file, except for the fact that I think it didn't have as much test data. We looked at the description of the test file, and now what we did is we put some coding in there to find out if there were any null values. And so you can see that there were null values in the outlet size and item weight in both the train file and the test file. So what I had to do was on the outlet size and the item weight for the train file and the test file, I had to convert that to mode, which means you just take the center of the file and put that value in there. Then what I did was after I replaced those null characters, I checked to see if there were any null characters, and you can see no, there were not any null characters. So now what we're doing is we're going through column by column to see what's going on. So we checked the item weight column. We checked to see if there were any null characters in item weight, and no, there were not any null characters. And that right there is just a blank character that got in, a blank column that just got in there somehow. Then what we did was we checked the item fat content, and you can see it had LF, low fat, and regular and reg. So what I did was I assigned a number of 0 to low fat and 1 to regular, and we mapped that into the column. So we replaced the text with a numeric value. And so you can see we did another group by function, and you can see the text was replaced with another numeric value. We wanted to see if there were any zero characters, and no, there were not any zero characters. So the next thing we did was we tested the item visibility, and that was a numeric character. So the only thing that I had to do was test to see if there were any null characters, and no, there were not any null characters. The next thing that we tested was the item type. And it says right here, there were 16 item types. So what we had to do was we had to assign a number to each item type, and then map that into the column. So we checked again, and we had numbers instead of characters, and that's what the computer wants. We tested to see if there were any null values, and no, there were not any null values. The next thing we did is we wanted to check the retail price, and that was a numeric value. So we just left it as it was, and we checked if there were any null characters, and no, there were not any null characters. The next thing we did was we checked the outlet identifier. And so what we had to do is, in order to make it a numeric value, we had to strip the OUT0 from the train file and the test file of that column, and that converted it to a numeric character. And then we tested to see if there were any null characters, and no, there were not any null values. The next thing we did was we wanted to check the outlet establishment year, and those were numeric values. So we did not do anything with that data, but we did check to see if there were any null values, and no, there were not any null values. The next thing we did was we checked the outlet size, and it was high, medium, and small. So we had to assign numeric values to high, medium, and small, and map that into the train file and the test file. And then so what we did was we tested to make sure that it was a numeric value, and you can see that it's now a numeric value. And then we tested to see if there were any null values in that column, and no, there were not any null values in that column. The next thing that we tested was the outlet location type, and that started with the string called tier. So what we had to do was we used the lstrip command to strip out the tier, and that converted it to a numeric value. And we tested to see if we had any null values in the column, and no, there were not any null values in the column. The next thing we tested was outlet type, and the first thing we had to do was, since it was a string of characters, we had to strip out the word supermarket type from that stream of characters. And you can see it left it with numbers 1, 2, 3, and grocery store. So the next thing we did was we plotted a numeric value to 1, 2, 3, and grocery store, and we mapped that into the train file and the test file. And then what we did was, again, we tested to make sure that 1, 2, 3, and 4 were viable. And yes, it was viable. And we tested to see if there were any null characters. And no, there were not any null characters. So after we did all this data manipulation, you can see the train file, and you can see where all the strings have been replaced with numbers. And exactly the same thing was done with the test file. The only string is the item identifier, and that item identifier is going to be used at a later time. So what we had to do is we had to define our X, Y, and X test. So X is item outlet sales, and features is item weight, item fat content, item visibility, item type, item MRP, outlet identifier, outlet establishment year, outlet size, and outlet location type. X was get dummies DF train features, and X test was PD get dummies DF test features. So what we did was we used a scaler to scale all of the numbers down to the same level. And so X equals scalar fit transform, and you can see X is now an array. We scaled the X test as well, and you can see the X test is now an array. And so what that does is that gets all of the values to a same range. And then what we did was we split our train set into train X, val X, train Y, and val Y using the train test split. And train X equals test data imputed copy all features. And the next thing that we did was we wanted to see the shape of training and validation set. So you can see train X was 6392 rows by 20 columns. Val X was 2131 rows by 20 columns, and train Y was 6392 array, and val Y was 2131 array. And the next thing we did was we imported Keras, because we're going to be using Keras on top of TensorFlow to form this prediction. And we imported TensorFlow as TF. We imported the module sequential. And from Keras layers, we imported input layer and dense. So we wanted to see the number of input neurons. So the input neurons is the shape of train X. We wanted to see the number of features. So the number of features was train X shape 1. We wanted to define our input neurons. So the input neurons was train X shape 1. We wanted to define the number of output neurons, and that was 1. We wanted to define the hidden layers and neuron in each layer, so that was 2, 10, and 5. And then we defined the architecture of the model that we're going to be using. And so activation was something called ReLU, and the very last model was linear, because we're going to be using linear regressive techniques. Now we've got a summary of a model, so you can see what the model looks like. And so you want to see the number of parameters between input and first hidden layer. So that's 200. See the number of parameters between the first and hidden layer, and adding the bias for each neuron of the first hidden layer. And that's 210. And we set the number of parameters between first and second hidden layer, and that's 55. The number of parameters between second hidden layer and output layer is 6. And so we've compiled our model. And so we wanted to see train X after we compiled the model, and you can see that it's an array. And then what we did here was we converted the train X, train Y, val X, val Y into a format that TensorFlow could accept. And so I got this off the internet, so we're converting it to array, because when I first started using it, I got an error message saying it wasn't the right format. And I looked on Stack Overflow, and Stack Overflow said that was the way they could correct it. So that's what I did. This right here is just converting the data into a format that TensorFlow can accept. So model history is where we fit the model. because you have to fit the model. And you can see we have all of these epochs. We had 50 epochs. Now what we did was we wanted to predict on the model, but we predicted on X test, which is the test file. And I wanted to see predictions, which was an array. And I wanted to see predictions again. That was just a bleep on my part, but we wanted to see the shape, which was 5681 and one column, and predictions was a two-dimensional array, but we needed a one-dimensional array. So what we did was we used the flatten command to convert predictions to a one-dimensional array, and you can see we used indim to show that predictions is now a one-dimensional array. And so this was the sample submission. So this was the format that our submission needed to be in. So what we had to do was, in order to get the submission into the correct format, we had to insert an OUT0 into the df._test outlet identifier. So the output was PD data frame, item identifier was DF test item identifier, outlet identifier was DF test outlet identifier, and item outlet sales was predictions. And that was made into a CSV file called submission CSV. And you can see the output right there, the item outlet sales prediction. And so I didn't know what I was going to get. I just thought, well, if I get anything at all, I'll be happy. And I was surprised that I got such a good score. And because I got such a good score, I wanted to make a video on it. So this is on my GitHub account. And you can always look on my GitHub account because it is... it does work. I submitted it on Analytics VidHaya, and I got a score of 1154.4027, which, in my opinion, it was a very good score. So let me know what you think about my video. And if you like my video, please like, subscribe, and share. If you like the work I'm doing, I've got my email address to my PayPal account down below in the description because I don't have enough subscribers. And the only way I can make money on YouTube is to ask for donations. Thank you very much for watching my video all the way to the end, and I look forward to making the next video for you.